In this video, we're going to use a logarithmic function in an application. And this application will be for earthquakes. Now, the intensity I of an earthquake is measured by a seismograph, a device that measures amplitudes of shock waves. Now, I naught is the minimum reference intensity of a zero-level earthquake against which the intensities of other earthquakes may be compared. The magnitude m of an earthquake of intensity I is given by the equation m equals the log of I divided by I naught. So to start, we're going to determine the magnitude of the earthquake that devastated Haiti on January 12, 2010. If the intensity was approximately 10 to the 7.0 times our I naught. So to work this problem out, we're going to take our equation m equals the log of I over I naught, and we're going to plug in the values that we have. So m equals the log of, we're going to have 10 to the 7.0, and we're getting that number from right here. And it says times I, right? So times I. So times our I naught. And the equation says to then divide that by I naught. And as we're doing this particular problem, we're going to be able to cross off our I naughts right here. Thus, we're able to say that m equals the log of 10 to the 7.0 power. And because our log here has a base of 10, because it's a common log, and here we have a base of our exponent of 10, we are then able to cancel those out, and it's going to tell us that the magnitude was a 7.0. So the magnitude of the earthquake that devastated Haiti on January 12th of 2010 was a 7.0. Now we're being asked to determine the magnitude of the earthquake that occurred near Washington, D.C. on August 23rd, 2011. If the intensity was approximately 10 raised to the 5.8 times our I naught. Now this problem is going to work out very similarly to how we did our last one. So we've got our equation, and we're going to have 10 to the 5.8, and then we're timesing that by our I naught, and then divided by I naught. Cancel out those I naughts. So our magnitude is going to be the log of 10 to the 5.8, because our common log and our exponent share the same base. We're able to cancel those out. And here we're going to have a magnitude of 5.8. So the magnitude of the earthquake that occurred near Washington, D.C. on August 23rd of 2011 was a 5.8 magnitude. Question C, or our last question, says how many times more intense was the earthquake that hit Haiti than the earthquake that hit Washington, D.C.? Round to the nearest whole unit. Now you would think that you could just take that 7.0 from up here and subtract it with our 5.8 to get our answer. But that is not going to work. It's not quite that simple. So here's what we're going to do. We're going to take our equation. So we're going to have our 10 raised to the 7.0 times our I naught, and we're going to divide that by 10 raised to the 5.8 times our I naught. Our I naughts are able to cancel out, and we're then able to plug this into our calculator, or we can see that because we have this same exponent, that means we can just subtract because we have the same bases, we're able to subtract the exponents. So if I was showing the work for that, it would look like 10 to the 7.0 minus 5.8, right? And so this ends up giving me basically a 10 to the 1.2 power, which comes out to approximately 16, which is a lot more than if you just take 7.0 minus 5.8. So you're able to say then that the earthquake in Haiti, let's not say that, say in Haiti was approximately 16 times more intense than the earthquake that hit near Washington, D.C., which is a lot.